Till now we have seen DFAs, many questions for which we have constructed DFAs and NFAs, but then I told you that whatever answers I have given you are the minimal DFAs, which means if you construct a DFA on your own, you might not get the same answer which I got, but then I have got all the minimal DFAs because of experience, that's it. Now the question is, can we take any finite automata, any DFA, only DFAs, can we take any DFA and prove that this is the minimal, or that such a DFA can even be minimized? So that is called minimization. So if a DFA is given, then we can apply a procedure using which we can decrease the number of states in the DFA. It is also called as minimization of a DFA. So before going for minimization of a DFA, let's talk about how we can minimize it, or what are the properties that we need in the DFA so that it can be minimized. We want to talk about states and equivalence between the states. Let us say there are two states, one is P and other is Q. We say that these two states are equivalent, and these two states in a DFA can be replaced by a single state if the condition is, if P on seeing W, which means the state P on seeing any input symbol, on seeing any input string, so W can be any input string, if this one goes to final state, it implies that Q also goes to final state, one of the final states. If in case P does not go to final state, then it implies that Q also does not go to final state. Try to understand this. Now if I have two states, let us say PQ, when can I combine them into single state is, they both have to be equivalent. I say that P and Q are equivalent when P on seeing any input string, if it is going to one of the final states, implies that Q should also go to one of the final states. Need not go to the same final state, but then they should be either final state or non-final state. If P is going to non-final, then Q should go to non-final. So if any two states follow this property, then we can say that such two states are called equivalent. If length of W is, mod W is 0, then both states P and Q are called 0 equivalent. 0 equivalent. If length of W is 1, which means if I see a single symbol and if they are following this property, then I can say that both states are 1 equivalent. If length of W is 2, then I can say that both are 2 equivalent. In general, if length of W is n, then I can say that both these states are n equivalent. And finally, if for every possible W, if this is the property being followed by P and Q, then I can say that both these states are equivalent, and instead of having two different states, I can merge these two states into one, and I can decrease the number of states in the final answer. So why to use this equivalence property and 0 equivalence, 1 equivalence, 2 equivalence, I'll take an example and I'll explain you with that. So let us say this is the finite automata DFA. So we are going to minimize only DFAs, not NFAs. This is the final automata, which is a DFA, and I want to minimize the number of states in this. First step is identify the start state and identify the final state. Now in this DFA, if there are any states which are unreachable or unaccessible or inaccessible, which means if there is any state from, if let us say there is a state like this Q5, and it is simply like this, A and B. If there is any state to which we cannot reach from the initial state, then we have to delete it. Step number 1 is try to delete all the states to which we cannot reach from the initial state. If you look at this diagram, all these states are reachable from initial state. Q0 is obviously initial state, Q1 is reachable, Q2 is reachable, Q3 is reachable, Q4 is reachable. All these states are actually reachable from the initial state. Now find out or draw the transition table, state transition table. Q0, Q1, Q2, Q3, Q4. A, B. Q0 on A is going to Q1 and Q0 on B is going to Q2. You can let us see the diagram. And Q1 on A is going to Q1 and Q1 on B is going to Q3. And Q2 on A is going to Q1 and Q2 on B is going to Q2. And Q3 on A is going to Q3 on A is going to Q1, Q3 on B is going to Q4, Q4 on A is going to Q1 and Q4 on B is going to Q2. What is initial state? Initial state is Q0. What is the final state? Final state is Q4. Therefore Q4 I am going to mark it like that, and wherever Q4 is there I will just mark it like that. Okay. Now first point is try to find out the zero equivalent states, zero equivalent sets. Try to find out the zero equivalent sets. I'll write here zero equivalent sets. So zero equivalent sets are nothing but try to separate non-final states from final states. What are the non-final states? Q0, Q1, Q2, Q3. What are the final states? Q4. So initially this is the starting point. Start with zero equivalent. Zero equivalent states are, these are all zero equivalent and these are all zero equivalent, which means set of all non-final states and set of all final states. Once it is done, now we have to find out one equivalent states. Now take the previous states. For example, you have to see, let us say previous state is in the previous zero equivalents. Take each one of them. See, all these states are zero equivalent, so we have to see whether they are one equivalent or not. Let us take Q0 and Q1, and let us see if they are one equivalent or not. If in order to see that, you have to take both of them and see where they are going on symbol A and symbol B. If you see Q0, it is going to Q1, and if you see Q1, it is going to Q1. Both are going to the same state. And if you see Q0, it is going to Q2, and if you see Q1, it is going to Q3. In the previous state, in the zero equivalent state, Q0 and Q3 are in the same, or I'll just draw a diagram here and I'll show you. See this? Now I'm checking for one equivalence of Q0 and Q1. So go to the diagram and you just draw like this: Q0 and Q1, these two, Q0 and Q1, these two. Now these two have to be in the same state in the above state. In the above state, which is zero equivalent, Q1 and Q2 are in the same group and Q2 and Q3 are in the same group. Therefore you can say that Q0 and Q1 are one equivalent. Now let us say these two are one equivalent. Now we have to see if Q2 is equivalent with any one of them. So if we have to see if Q2 is equivalent with any one of them, you can take either Q0 or Q1 and check with Q2. See this? I am taking Q0 or Q1. Q0 and Q2. Q0 is here, Q2 is here. Q0 is here, Q2 is here. Just check them. Q0 and Q2 both are going to Q1, which is there in the same state, and both are going to Q2. When they are going to same states, they are obviously equivalent. Therefore Q2 is equivalent to Q0. Since Q1 is equivalent to Q0, and Q2 is equivalent to Q2, therefore Q1 is equivalent to C. Already we know that these two are equivalent. Now we found out that these two are equivalent, therefore Q2 and Q1 are also equivalent. Now we have to check if Q3 is equivalent with any of these three. So you can take only one and you can check it. So you can take any one. Let me take Q2 and Q3 and check for the equivalence. So I'll take Q2 and Q3 and check for the equivalence. Q2 is where? Q2 is here and Q3 is here. Now see them. Q2 on A, they both are going to Q1, so on A it is not a problem, but on B, one is going to Q2, other is going to Q4. One is going to Q2, other is going to Q4. So both are going to different states here, different groups here. Since they are going to different groups, they are not in the same state, or they are not equivalent, one equivalent. Therefore, Q3 only is not one equivalent with the others. See, try to understand it. When I am writing one equivalence, I will be using the information only about 0 equivalent. When I am writing 2 equivalent, I will be using the information about 1 equivalent. You will understand this with more examples. I will solve more examples, don't worry. See, now I want to find out 2 equivalent states. In order to find out 2 equivalent states, again start with the same thing. This is also called as partitioning method. There is one more method called table filling method. I am not going to discuss it and it is very difficult. This one is pretty easy, right? Let us talk about 2 equivalent. Now already Q3 and Q4 are the only people in their groups, or are the only states in their groups, so there is nothing to do about them. They are saying that we are not equivalent with any states, so therefore we cannot combine Q3 and Q4 anymore. Now we have to decide whether we can combine Q2 and these three, Q1, Q2 and Q0. Now let us take Q0 and Q1 and see if they are equivalent or not. Q0 and Q1 and see if they are equivalent or not. Q0 and Q1. So these are the outputs I need to see. Now see this, Q0 and Q1 both are going to Q1 only, that is not a problem. Why? Because they are going to same state. Now on B, one is going to Q2, other is going to Q3. One is going to Q2, other is going to Q3. Both are in different groups. Whenever they are in different groups in the previous equivalence, in this equivalence they are not equivalent. Which means in one equivalent state, if they are going to different groups, then in 2 equivalent they are not equivalent. Which means Q0 and Q1 are definitely not one equivalent. Now what about Q2? See, Q0 and Q1 both got separated. I don't know whether Q2 is equivalent to Q0 or Q1. Where should I place? Whether here or here. So I'll just check it. Now let me see if Q0 and Q2 are equivalent. Q0 and Q2 are equivalent. In order to check it, if I have to check for 2 equivalent, go to the 1 equivalent and use this table. Q0 and Q2. These two. See this, on Q0 and Q2 on A both are going to Q1, and on B both are going to Q2. Therefore definitely they are equivalent. They are going to same states. Definitely they are equivalent. So Q0 and Q2 are definitely equivalent. Now what about Q1? It got separated. What about Q3? It got separated earlier only. What about Q4? Yes, got separated. So now we know these states are saying that we are not equivalent with any other states, therefore we have to have at least these 3 states, and now I don't know whether these two are going to be in the same group in the 3 equivalent or not. Let us say 3 equivalent. In 3 equivalent, again I have to check Q0 and Q2 only. Now if I check Q0 and Q0 and Q2, again the same result will follow. See this, both Q0 and Q2 are going to Q1 and Q2 only. Therefore these 2 states cannot be separated, or they are just equivalent. Now check this, 0 equivalent we got 2 groups, 1 equivalent we got 3 groups, 2 equivalent we got 4 groups, 3 equivalent we got 4 groups, and all the groups are same. So continue this method until we get 2 states like this where nothing will change from one another. If you even go for 4 equivalent, you will see the same thing. So on, go for n equivalent, you will see this, you will see the same thing, which means this is the final answer. So in the final DFA we should have only 4 states, and these 4 states are Q0, Q2, Q1, Q3, Q4. Now let us try to draw the diagram and show how does the DFA looks like. Now one state is Q0, Q2. Initially we had 2 states, now I am going to combine them as one state, and the other state is Q1 and the other state is Q3 and the other state is Q4. Okay, now look at this. Q0 on A is going to Q1 and Q0 on B is also going to Q1 only. Q0 on A is going to Q1 as well as Q2 on A is going to Q1. Therefore, Q0 or Q2 on A is going to Q1. Now, Q0 or Q2 on B is going to Q2 only. So, on B, check this. Q0 is going to Q2, therefore Q0 should go to Q2, and Q2 is going to Q2, therefore that is it, just B. Next one, Q1 is going to Q1 on A and Q1 is going to Q3 on B, and next thing, Q3 on A is going to Q1 and Q3 on B is going to Q4. Next, Q4 on A is going to Q1 and on B is going to Q2. So the initial diagram, this is the final diagram. So you can understand one thing, even though there are many states in the initial diagram, they can be states can be decreased if you find out some few states which are equivalent, and then instead of having 2 different states for all the equivalent states, you can have 1 state. Let us say if there are n states which are equivalent, for all the n states we are going to have 1 state in the final diagram. This is the minimization procedure.